Hey, so this class we're going to talk about partial fraction decomposition. So as an introduction, what you probably all know is how to add fractions with unlike denominators. So for example, if I asked you what is 1 over x plus 2 plus 1 over x plus 3, the way you do this is you'd multiply this by x plus 2 and this by x plus 2, and then multiply this side of the terms by x plus 3 and x plus 3. What that does is it gives us a common denominator on both fractions, and then we can actually add them up. So let's actually do this. We would get x plus 3 for the first fraction over x plus 3, x plus 2, and then plus, for the second fraction, we would get x plus 2 over x plus 3, x plus 2. And now since we have common denominators on both fractions, what we can do now is actually add them up. So this would give us x plus 3 plus x plus 2 all over x plus 3, x plus 2. And from here we can simplify a bit. So the top, or the numerator, it will give us 2x plus 5, and the denominator would stay the same as x plus 3 and x plus 2. And yeah, we're done. So you probably already know how to do this. But yeah, what partial fraction decomposition is basically the exact opposite. So if I give you this part, how would you get to the original question of having two fractions added together? That's pretty much it. So now you might ask, how do we decompose a fraction if you have any original fraction? So let's start off with an example of 1 over x plus 2, x plus 3. What this tells us, if we look at this fraction, is that first off, we're going to have two fractions added together because there are two terms in the denominator. We want to split them off so that one fraction has x plus 2 and the other fraction has x plus 3. This is our goal. We still do not know what the numerator is, so we're just going to leave it as this. And yeah, so just like I said, since we do not know what the numerator is, we can write a here and b here. These are going to be constants that we're trying to find so that this works with this, and then we have our answer and it's decomposed, and we're done. So another example, let's say we had 1 over x plus 1, x plus 2, x plus 3. It's pretty simple again. So you'd have a over x plus 1 plus b over x plus 2 plus c over x plus 3. Once again, all I did was I split the denominator into each term having its own fraction, and then I do not know the numerators, so I leave them and I try to find them later, which we're going to do after the explanation. But yeah, so if you find what these numerators are, that's it, you're done. You plug them in and you found the decomposed answer. Something else you might get, so you might have noticed that so far we've had linear denominators. So this is like x plus 2. The power of x is 1. It's x to the power of 1 plus 2. So we did not have any quadratic or any other type of exponent. So let's say we did have that. Let's say we had 1 over x plus 1, x plus 2, and then we had x squared plus 2. First, let's do the exact same thing for these two. We know it's going to be a over x plus 1 plus b over x plus 2. Now for the last one, since it's a quadratic, x has a power of 2, what we have to do is that the numerator is going to have a power less than 2. So what I mean is this, the denominator is going to be the same, so x squared plus 2. This always is done like this. There's no exceptions. You always have to just split these off and put them each into a different fraction. But then the only difference here is, once again, the numerator. For this one, instead of having c, you would have cx plus d. And now this is a linear. So all you have to know is that the exponent of the numerator is 1 less than the exponent of the denominator. Over here, x has a power of 1. Over here, x has a power of 2. Over here, x has a power of 1, but then on top, x has a power of 0. That's why there is no x. And same for this. So x has a power of 1, and x has a power of 0. So yeah, if you always decrease the exponent by 1, you get the setup. And then once again, for this question, after you basically write this down, all you have to do now is find what a is, what b is, and then what c and d are. And after that, you are done. So yeah, let's go on and move into some examples now. So for the first question that we have here, we have 1 over x minus 3, x plus 4. So first off, we can split these up into two different fractions, like I said before. Pretty simple. We know that the denominators are going to split off into two different fractions. This one's going to have a denominator of x minus 3, and the other one's going to have the denominator of x plus 4. Once again, put this here and put this here. That's it. And then we do not know the numerators yet, so I'm going to write a and b. Now let's actually find a common denominator and combine these. Once again, we have this. We are trying to get to this. So the first step we need to do is combine them to have one denominator and be one fraction. Right now we have two fractions. We want it to be one fraction. So this would be a times x plus 4 plus b times x minus 3 over x minus 3 x plus 4. All I did here was I found a common denominator, so multiply this fraction by x plus 4 on the top and the bottom, and multiply this fraction by x minus 3 on the top and the bottom. So yeah, now let's expand this a tiny bit. You get ax plus 4a plus bx minus 3b all over x minus 3 x plus 4. So yeah, now we have this fraction. It is what we wanted. We have one fraction, and we're trying to replicate this. So we already replicated the denominator. We don't have to touch that anymore. Now we have to replicate the numerator. We know that we want to get to a numerator of 1. Right now we have this monstrosity on top. So what we can do is equate it to 1. We know that the numerator, once again, is going to be equal to 1. So I'm just going to write that down. ax plus 4a plus bx minus 3b is equal to 1. From there, this is the easy step so far. First off, we know that the equation has 1 plus 0x on this side. What that tells us is that all these x terms have to cancel out because we don't have any x terms in the answer. So we know that a plus b must equal to 0. Once again, both of these terms, the ax and the bx, must give us 0x. So a plus b must equal to 0. For the other two ones, we know that 4a and negative 3b should add 1, because these are two constants. If you add two constants together, you should get 1 in this case, which is over here. And from there, it's pretty simple, so let's write that down too. We have 4a minus 3b is equal to 1. Now what we can do is multiply this this equation by 3. We would have 3a plus 3b equals 0. Once again, all I'm doing here is solving a set of equations. So now let's call this equation 1, and let's call this equation 2. And now let's add 1 plus 2 together, add both equations together. What we would get is 3a plus 3b is equal to 0, and then we would have 4a minus 3b is equal to 1. If you add these up as entire equations, what you get is 1 plus 0 is 1. Positive 3b and negative 3b cancel out, so we don't have a b at all, which is what we want. And then 3a plus 4a is 7a. So we have 7a is equal to 1, or in other words, a is equal to 1 over 7. So yeah, now we have a. Let's use any of these equations, either one, it doesn't matter. We can even use the original one because this is the simplest one so far. So we have if a plus b is 0, and you know that a is 1 over 7, so 1 over 7 plus b is equal to 0, b is going to be equal to negative 1 over 7. And we're done. We found what a was, and now we have b. Now let's go back to the original equation. So we had this here. I'm going to erase the pink notes. But yeah, so we had two fractions. Now we know what a and b are, so let's plug them in. It's as easy as that. So we're going to get, since a is 1 over 7, we're going to get 1 over 7 all over x minus 3 plus b is negative 1 over 7. So we're going to get negative 1 over 7 over x plus 4. And now let's make this look a tiny bit nicer because we don't like fractions to look like this. So this entire thing would be equal to 1 over 7 times x minus 3 minus 1 over 7 times x plus 4. And we are done. We just decomposed the original fraction into two smaller fractions, and we're done. this is useful for other things, but yeah, right now it might seem like a bit useless because you might not see a use in your head, but it is actually pretty useful and you'll learn uses later on. So yeah, we have our answer and we're done. Question number 2, so let's start off with the exact same things here. So first off, let's split them up into 2 different fractions. First one's going to have a denominator of x minus 2. Next one's going to have a denominator of x minus 3. First fraction is going to have a numerator of a, and then second one's going to have a numerator of b, because we do not know them yet. Now let's add these up and find a common denominator and just combine them into one fraction. So we will get a times x minus 3 plus b times x minus 2 all over x minus 2 x minus 3. So if it seems like I skipped steps here, you can try this alone, but all I did was I found a common denominator and I put them together as one fraction. That's pretty much it. And then after that, you can expand this, make it look nicer. We would have ax minus 3a plus bx minus 2b all over x minus 2 x minus 3. Now let's look back at the original expression. The denominator looks good because we have the same on both our answers so far and the original question, so that's good. Now we have to alter the numerator a bit because once again we have kind of almost like a monstrosity here, and then we have 6x minus 14 here. So what we do know is that ax minus 3a plus bx minus 2b is equal to 6x minus 14. Once again, all I did here was that I know that this numerator should be equal to this numerator. That's it. And now, from here, let's make 2 other equations like we did last time. So combining the x terms, we are going to get that a plus b is equal to 6. Because if you combine these, you should get 6x. And then for the other ones, I'm going to do them in green. Negative 3a minus 2b, these are both constants, should give us negative 14. So negative 3a minus 2b is negative 14. And now let's solve both sets of equations and we're basically done. So this will give us, let's make all this positive on this side. So 3a plus 2b is equal to 14. And now let's multiply this equation by 2. We would get 2a plus 2b is equal to 12. And now so far, if we call this equation 1 and we call this equation 2, let's do 2 minus 1. Equation 2 minus equation 1. So if I'm going to write that down, this will give us 3a plus 2b is equal to 14, and then 2a plus 2b is equal to 12. Let's subtract these 2 equations together. 14 minus 12 is 2. 2b minus 2b is 0. It goes away. And then 3a minus 2a is a. So we have that a is equal to 2, and we're done with that. And then for b, let's use any of these equations again. I'm going to use the simpler looking one. So I know that if a plus b is equal to 6, and if a is 2, so 2 plus b is equal to 6, b must equal to 4. So from there, we know that a is equal to 2, b is equal to 4. Let's put these back into the original equation. So we would get 2 over x minus 2 plus 4 over x minus 3. And we are done. All I did, once again, put the a and b values that we got into the original variables to get the new looking equation over here. So we successfully decomposed a fraction to be 2 smaller fractions that we can use later on. So question number 3. In this one, you might say, since this is a quadratic, we're actually going to use the second format and say that this is going to be equal to ax plus b over x squared plus x minus 2. But this is wrong, because right now we can actually split this up and factor it first. So we know that x squared plus x minus 2 is going to be x plus 2 x minus 1. So all I did was I factored it out. And now we have 2 linear terms that we can now split off into a over x plus 2 plus b over x minus 1. And that's it. We are done. Once again, all I did was I first factored it out, because you always have to check to make sure that you can or cannot factor before moving on. If you can, do it. And then after doing it, you can now get this and do what we have done multiple times. So combine the fractions and have a common denominator. So this would be a times x minus 1 plus b times x plus 2 over x plus 2 x minus 1. And now we can actually expand this and see what we get. So ax minus a plus bx plus 2b over x plus 2 x minus 1. So now let's actually see what a and b are. We know that this entire thing should be equal to 1 because that's what the numerator of the original question was. So let's write that down. This entire thing, so ax minus a plus bx plus 2b is equal to 1. Once again, all I did was I equated what we have so far to the original question. That's it. And then from here, we know that we have a 0x term because we have no x's. So we know that ax plus bx should give us 0x. In other words, a plus b is equal to 0. Now for the other ones, negative a plus 2b should give us 1 because both of these are constants. So negative a plus 2b is equal to 1. Now let's find out what a and b are. We can add both equations. So let's call this equation 1. Let's call this equation 2. Add 1 plus 2 together. We would have a plus b equals 0 and negative a plus 2b equals 1. Add them up as equations. 1 plus 0 is 1. 2b plus 1b is 3b. And then a plus negative a is 0a. So we don't have to even write that down. So now we have 3b is equal to 1, or in other words, b is equal to 1 over 3. And we are done finding b. Now for a, let's use equation 1 to find that. If we know that a plus b is equal to 0, and we know that b is 1/3, a must be equal to negative 1 over 3 using basic algebra. And we're done. So we found what a and b are. And now from here, the easiest step, let's plug them back into the original equation that we have here. So if a is negative 1 over 3, let's write that down. So negative 1 over 3 over x plus 2 plus, and then b is 1 over 3, so 1 over 3 over x minus 1. We're basically almost done, but we're going to try and make this look nicer. So we're going to have negative 1 over 3x plus 2, and then plus 1 over 3x minus 1. And to check this kind of answer, this is the easiest thing you can always do, but kind of combine it together using the answer that you got and see if you get the original equation back. And that's pretty much it. So we're done this too. So for the last question of the video, first we have x over x cubed minus 1. For this question, we must notice that x cubed minus 1 can be factored into x minus 1 times x squared plus x plus 1. You should know this as a cubic factoring rule. Go back to kind of review those if you find trouble getting that. But yeah, so this should give us x over x minus 1 times x squared plus x plus 1. So now from here, we can do what we always do, but this time we actually have the quadratic equation or expression that I was talking about earlier. But yeah, so this will become a over x minus 1. And then for the next term, we're going to have bx plus c over x squared plus x plus 1. Once again, we have bx plus c because it is a linear term since this is a quadratic term. The exponents have to be always one less than the denominator. So yeah, from here, let's combine these and give them common denominators. So a times x squared plus x plus 1 plus bx plus c all multiplied by x minus 1 over x minus 1 x squared plus x plus 1. So now we have the same denominators, so that's done. We don't have to touch the denominators anymore. Now we have to expand the numerators and kind of try to get x from that. So let's expand. This will become ax squared plus ax plus a plus bx squared minus bx plus cx minus c. And then all of this is over x minus 1 times x squared plus x plus 1. So now this numerator has to be equal to x once again. So let's write that down. Ax squared plus ax plus a plus bx squared minus bx plus cx minus c is all equal to x. So this is pretty long, but we can do the exact same steps again. We know that ax squared and bx squared must give us 0x squared, because you don't even have that in the answer. So all these should combine to 0. So we know that a plus b is equal to 0. Now for the x's, we have ax, negative bx, and cx. All these should combine to give us x. So we know that a minus b plus c is equal to 1, because we have 1x here. So recap, a minus b plus c equals 1. So after that, we're done that. And then one last equation, we have two kind of constants. So a and negative c. And that once again should give us 0, because we don't have any constant term here. So that would give us, I'm going to write this in yellow actually, but a minus c equals 0. So after getting all three equations, let's call this equation 1, equation 2, and equation 3. Now let's add equation 2 and 3 together, because we want to get rid of these c's. Doing that, I'm going to write it down actually, but so a minus b plus c equals 1. Add it to a minus c is equal to 0. So yeah, add these together. 1 plus 0 is 1. The c goes away. We have negative b, and we have a plus a, which is 2a. So 2a minus b equals 1. And now let's add this to equation 1. So let's call this equation 4 actually. So 4 plus 1. That would be 2a minus b equals 1. Add it to a plus b equals 0. So once again, if you add these together, we should get 1, b goes away, and we have 3a. So we have 3a equals 1. So a equals 1 over 3. And now we're basically almost done. If you know that a is equal to 1 over 3, b must equal to negative 1 over 3 from here. So b is equal to negative 1 over 3, because 1 over 3 plus b is equal to 0. So b has to be equal to negative 1 over 3. And now since we now know a and b, let's find c. So we know that a is 1 over 3, b is negative 1 over 3, so minus negative 1 over 3 plus c equals 1. So this is 2/3 plus c equals 1. In other words, c is equal to 1 over 3. Once again, this is just algebra after finding the three equations to find what each of a, b, and c are. And that's it. So once again, quick recap. A is 1 over 3, b is negative 1 over 3, and c is 1 over 3 as well. And yeah, so since we know that, let's put it back into the original equation. So we get a, which is 1 over 3 on top, over x minus 1, plus b is negative 1 over 3, so negative 1 over 3x, plus 1 over 3, all over x squared plus x plus 1. One final step, we are almost done. This is going to be equal to 1 over 3 of x minus 1, and then this is going to be equal to plus negative x plus 1 over 3 of x squared plus x plus 1. And we are basically done. You could technically change this to have the x as a positive number. So this will become 1 over 3 of x minus 1 minus x minus 1 over 3 of x squared plus x plus 1. And we are done. This matches the original equation. And now you can always check this once again, but if you combine these, you should get the original expression of x over x cubed minus 1. So we're done.